What is API in essence? API is a set of functionality, broadly speaking. It can be shipped as a whole library, or it can just be a class. Every programmer produces APIs in one form or another. Good programming is modular, what inherently means that those modular boundaries are APIs by themselves. Good APIs tend to get reused. They can become a great asset. On the contrary, bad APIs become liabilities. There are nice APIs, there are nasty APIs, but there are no perfect APIs, definitely. The perfect API is something unrealistic. If you develop a class for internal usage within a company, you develop a private API for the other developers inside your company. This kind of environment, in which the code lives, Mark Simon calls a zoo. If you develop a class for the public, it is a public API which can be potentially used by millions of developers all over the world. This kind of environment in which the code lives, Mark Simon calls wilderness. These two major cases are different, but how much they are different we will consider a little bit after the introduction. By the way, you can read a great article about rangers and zookeepers by Mark Simon following the link I have attached. Firstly, it would be very nice to define characteristics of a good API. We will mark out the following characteristics: simplicity, expressiveness and compromises, extensibility, and consistency. Now let's dig deeper into characteristics of APIs. The first characteristic, simplicity, can be described through the well-known rule concerning APIs development. You can always add, but never remove. This means that if there are many users of your API, you can't remove functionality they already use. That's why developing your API, it's always preferable to defer questionable functions rather than include them into the current release. Of course, the previous statement is also about API versioning, but we consider it in the context of finding the balance between power and simplicity. So here, we face a compromise between power and simplicity. When power, or in other words, abilities expressed in functionality of an API grows, its simplicity degrades. The balance is hidden somewhere in the golden mean. So one of the most interesting questions here is how to estimate the simplicity of an API. Unfortunately, there are no algorithmic ways to calculate any meaningful coefficients of simplicity of an API. The only way to understand whether an API is simple or not is to estimate the time spent on understanding it by its users. This method allows to build a learning curve of an API. If the API simplicity of which you are trying to analyze is relatively small, say if it's not a huge framework, then you can give it to a couple of your colleagues and watch how many time will they take to understand your API and how many times they will require comments or any documentation of the API. This one simple step will show whether the API is simple enough comparing to your requirements for simplicity or not. So, firstly, you can set a time limit on understanding your API, then ask your colleagues to try to use API's functionality, and then compare your premise with real results. Going this way, you'll be able to take a decision to make your API simpler or to stop at the current point. Things getting more complex when API is expressed in terms of a certain domain model. In this case, you have to find those who are familiar with the domain model and those who are not. Why both? Because programmers are human resources and they can leave a company at any moment. This may lead to the situation when a newcomer will take the responsibility to work with your API. So you have to understand how many time will it take to understand your API in both cases. These thoughts lead to the next characteristic of a good API. Good APIs are expensive, because in order to make them simple, it's necessary to spend much more time than just ship all as is. Unfortunately, not only simplicity suffers from underinvestment. Mistakes have a tendency to accumulate, and the design begins to rot. Consequently, it leads to a big ball of mud instead of clarity, and in the end it leads to bugs. Resources which can be allocated to API development are always limited, so obviously we can't polish APIs for a very long time. That's why there are always compromises between power and simplicity. By the way, in spite of striving to create a super powerful API, it is almost impossible to create universal APIs. It means that API developers have to implement first things first. To understand the main scenarios, it is necessary to analyze abilities, advantages, and flaws which will be faced by the user in all different ways of implementing API. Extensibility is the next major characteristic. This characteristic reflects the capabilities to increase the power of an API without big rewritings. There are a couple of nuances regarding this characteristic. We can look at extensibility from the perspective of adding new functionality and preserving the backward compatibility. The design should strive to be capable of adding new functionality. The main object-oriented principle in this case is the open-closed principle, which means that an object should be opened for extension and closed for modification. I would say that mostly this principle is applicable to the zoo APIs, e.g. private APIs. As to public APIs, is that we at first should not roll out features which could contradict with the functionality which may be introduced in the future. If you are in doubts, it's better to not introduce an API member than to introduce it. When we're talking about public APIs, we should at first preserve the backward compatibility. Changing an existing API so it will break any existing clients is the greatest sin. Unfortunately, this sin cannot be avoided sometimes, but you should strive to break clients' code as rarely as possible. An API has to be logical and consistent. The consistency of an API means that decisions applied to the design of that API are strongly opinionated. There always will be different choices available with their advantages and disadvantages. But API designers should take a side and stick with it along all the way. Let's look at a bad example of poor consistency. The PHP string library exposes the following methods. Apparently, there's an inconsistent naming of methods. It looks like developers were in doubt and hesitated about which style of naming they should stick with along the way. The best option in this particular case was to use underscores everywhere. A worse way was to use everywhere the conjoint naming, and the worst possible way is to use everywhere different naming styles. The worst possible way is exactly what PHP string API designers have chosen. Now, developers should bear in mind two different naming styles and remember when to use which. This is really insane. Okay, we have discussed the characteristics of APIs. Now, let's briefly talk about public and private APIs. The marked-out principles are more important for building public APIs. Public APIs put greater responsibility on you than private APIs. That's why you have to strive to make better that characteristics as much as you can. The cost of bad decisions may be extremely high. What I just have told doesn't mean that private APIs developers don't need to take into account those characteristics. I'm a strong believer in that private APIs should be developed bearing in mind all that characteristics. The repercussions of low-quality private API designing might be horrible. The thing is that layers are built on top of other layers, as well as applications often built on top of other applications. So, introducing breaking changes into private APIs might have a very bad impact on dependent modules and entire applications. The corollary of this fact is that zookeepers must strive to become rangers anyway. Thus, all the techniques we will discuss in this course are applicable to developing both private and public APIs. More on the topic you can read following the links attached to this lecture. Okay, let's talk a little bit about API development principles. There are some development principles which help us to create APIs with great or at least satisfactory characteristics. Let's look at them more closely. APIs should be as simple as possible, but no simpler. This is the principle firstly spoken by Albert Einstein. This is a general principle which is applicable to many things in our life. In the context of APIs development, this principle implies that simple things should be simple and at the same time difficult things should be achievable. In practice, it also means that when you are in doubt about introducing a certain member, just leave it out. Remember again that you can always add but never remove. This rule is more relevant for public APIs, but don't forget that introducing breaking changes in private APIs is also a heavy sin. A good API should allow to do a lot without learning a lot. In practice, it means that you should strive to build APIs which are simple to use in order to accomplish simple tasks, and on the top of these simple scenarios, more difficult tasks should be possible to accomplish. Did you notice? The first principle resonates with the second one. Actually, all the principles are intertangled. They all have something in common. APIs should be based on use cases. As a practical corollary, we can say here is that it means two things. The first one is that in order to design an API, just imagine that you are a client of that API. Write some code which uses that just yet inexistent API. How the client's code should look like? Do you like the code you've written? The second thing is that you have to start to make a sketch of an API as soon as possible. Don't gather tons of requirements. Just make a simple sketch and ask other developers what do they think about your design. So, the first thing you should do is to write several code samples for the main use cases. Ask your colleagues to implement that main use cases. If they experience difficulties, it's a bad sign. Provide a low barrier for using an API. In practice, it means that you always should provide the simplest constructors with default values for parameters. Should throw exceptions with messages which explain what to do to fix the problem. Should not require from clients to explicitly create more than one type for accomplishing main use cases. Should not require from clients to perform a wide initialization of an object. Build self-explanatory APIs. I would express this thought in other words. Let API clients to rely on IntelliSense. API clients should understand the API by just using the IntelliSense. So, an API has to be understandable intuitively. In spite of the previous point, you should provide a decent documentation. In the case of private APIs, this is especially important for APIs which contain domain notions, what inherently makes them hard to understand, especially for those who are only at the beginning of learning the domain concepts. In the end, I would say that your API should appeal to the most powerful emotion. Which one? Do you think love? Not exactly. Appeal to the laziness. No one wants to learn a book a hand in thickness about using your API. No one, even you.